Hi. Welcome to the lecture on actually the last chapter of the textbook. This one is on radio frequency identification and near-field communication. So it's the last chapter in our Introduction to Wireless class. So hope you've enjoyed the class and get a little information on RFID and near-field communication in this lecture. So in this essay, we are going to define what RFID and near-field communication is. We'll look at the components in them. We'll explain some of the challenges in security. So actually, we'll also talk about how they work. Probably spend more time there than we will on security and other measures. So what is RFID? RFID is similar to barcodes, but instead of a laser light, it uses radio frequency waves to read a product information. And instead of having a printed label, as with the barcode, the store would actually store information on a electronic tag that actually contain an antenna and a small microprocessor chip on it. Now, the standards set for RFID are established by a company called EPC Global Inc. So they use work with OSI as far as setting up the standards, adopted the ISO 18000 series standards for RFID, which includes things that we've talked about, frequencies, what frequencies are going to use, and how the physical and MAC layer specifications are established. So, of course, you've probably realized when you start defining physical and MAC layer information, you're definitely talking a realm of communication between two electronic devices. Now, some of the components of an RFID, we've all seen the RFID tags, but you forget that the antennas are built into the tag. And then, of course, typically because I have a tag, I also need to have a reader. So you've got tags, antennas, readers, software, and services that are offered. So let's look at, some of the code. Now, what type of information is stored on one of those tags is an electronic product code. It's a standardized numbering scheme that can be programmed into a tag and then attached to a product. This can be a unique number. Usually it's represented in hex notation. So similar to a MAC address for a network interface card. You're talking about now. Granted, you're seeing here this are instead of the length of a MAC address, its EPC code is either 64 or 96 bits long, and I think there's some discussion about going to 128 in the near future. But it's written in hex, so it gives you a whole lot more information. About that. So this electronic product code that's stored on an RFID has a format similar to this is the 96-bit code, and you've got header information, a domain manager, object class, and serial number. As far as its 4 different parts to it. Now, the structure of those codes, you've got several different styles or sizes, different types. A lot of it just depends on which way you're going to go, which product you want to use, how you're going to identify it. But at least once you select one for your company, then you got to make sure you're consistent. Now, the RFID tags themselves are commonly known also as transponders, and basically it's just a transmitter receiver built into one device. It's an integrated chip. It contains some non-volatile memory and a small, simple processor. Now, it can store data that can be interrogated by a reader. And a reader is just a device that captures and processes data received from the tag. Now, there are some different types of tags. There's 2 basic types. There's passive and the active. Passive is definitely the most common because they're cheap. make in a large quantity and only use electromagnetic energy in the RF waves. So they don't use batteries. So basically, it's when the reader hits it, does it activate the passive tag to transmit, and kind of uses the RF waves to power itself, the tag's processor up to transmit the data. Now, the active tags definitely are equipped with batteries. They can transmit further distance, but of course, because they have a battery, they have, limited lifetime. Granted, they're longer lifetimes because I'm not radiating a lot of energy or power, but it is a limited lifetime. And just give you a rough idea, you've got a microprocessor and the antenna. As far as this is a passive tag that you're seeing here. Now, there are there's a third type that's kind of a semi-active tag. It's got a built-in battery, but you first have to have the reader, energize it, and then the battery takes over to start it. So the battery will last longer, but definitely not as long as a passive tag. Now, the size of the tag varies between, how much memory you're going to put in there, between 16 bits and hundreds of kilobits. So it just depends on how much information you want to track, how long you want to track it, what information. If you were going to use these for livestock, you may want to do it from birth to death, where they roam, what they ate, so just tons of information, and how long you want to keep it. You may want to make sure you have more data stored than less. Now, granted, tags are initially programmed with a unique identification tag, similar to your MAC address, where you had a predefined manufacturer ID that somebody else defined. Well, in this case, you get a code to start with, and then you have to program additional information into it. Now, there's one other type here that's coming up here is called smart labels. And it basically a flexible RFID tag. So you can do other things to it. Now, it can be read regardless of position, orientation, and it definitely has an advantage over RFID over barcodes. With a barcode, you wouldn't go to the grocery store with a barcode and try to read it. You got to have the package in the right. Well, smart labels is just I can go anywhere I want in that. It can be any position, located, and it still can be read. Now, there's another tag, the 1-bit tag, and you get some of these stores, it's a passive tag, and it basically is used to trigger security alarms. If you go to Best Buy or something like that, and you see this code, and you kind of scan it across to kind of deactivate that code, those are probably 1-bit tags. Now, there are other new ones coming out called chipless tags, or basically RF fibers. And basically, it's material and fibers that will actually reflect some of the reader's information back. So you store some information on the fibers, and then when the reader hits it, it reflects that information or sends it back to that. So just here's a sample of passive and a 1-bit tag. You've probably seen a lot of the 1-bit tags compared to a barcode. So now, there are some things called a sensory tag, which has definitely various kinds of sensors monitored, environmental things that can kind of use to prevent tampering with a product. Of course, because there's so many different types and what you can, the cost of that will depend on the type of tag you're getting and the quantity of them. Now, there are basically 4 classes of tags. And actually there's a 5th, but class 0 is pretty much dead and buried already, so you don't have to really worry about that. So you got class 1 is passive identifier, all the way up to class 4 being an active. So it's definitely based on what you're trying to do, how you want to identify your products and keep track of them, what information you want. You have to make a choice as far as which type of tag you want to use. Now, of course, if I have a tag, you have to have a reader. So that, or in this case, it's also called an interrogator. But it's just devices that connect to a company's network that can transfer the data from the tag into a computer. Some writers can write information onto tags. Some readers that are working with passive tags will actually be able to provide energy that activates the tags. Now, how far your reader's got to be away from your tag just varies on the size of the tag, the type of antennas, both on the reader and on the antenna, and as the amount of power is transmitted. So just rough idea as to some frequencies and common applications. All of these, I guess I haven't used the low frequency as far as animal protection, but definitely electronic toll we've all used. So different types of readers, from wands to sensors, just tons of information, as far as different types of readers. Now, as with any wireless device, you got what? I have to have an antenna. RFID antennas are used in the tag itself. Now, granted, they're limited in how big they are based on the size of the tag. Now, there's basically two types. There's a linear and a circular. The linear gives you a greater range, but your readings are less accurate. Circular, you get a more accurate read, but it has definitely a more limited range. Now, the larger the antenna, guess what? The larger distances you can read. Of course, also as the frequency increases, so the wavelength gets smaller, so does the antenna. But, and even though the high frequency can make the tag smaller, it's still that high frequency will allow me to read it at a greater distance. So basically, I like this last bullet item, no typical style. So basically, whatever your application is as you're designing this tag, you've got your choice. You're going to pick and choose your antenna, your reader, and how you want to do it. And here's just tons of different samples and ways that are being implemented in today's technology. Now, okay, you've talked about tags, readers. Now let's look at the software. Now, software depends on what application you have. Now, there's a couple of different components to the software. There's system software used to control the hardware and functions, both on the tag and the readers. There's middleware that's responsible for reformatting data from the readers, back going to a business application. And then, of course, the business application itself, it's responsible for, processing the orders and inventory shipping and invoices, normal business stuff. And then the last part of this is services, EPC Global Network Services. And it basically, EPC tries to reduce the need for cross-referencing information. And basically what it's trying to do is has what they call an object name service. And it's a mechanism for discovering information about a product and related services. And this could be over long periods of time, which will lead into some of the security issues we'll talk about later. But when the reader gets a tag from an EPC, it passes it on to the company servers, which then send it over the internet, and then it basically can store that information on a server. So it should involve or allow people to track purchases and invoices and track product orders over the internet, eliminate to send paper documents. So there are just tons of information that could be offered. And just a rough idea. And as you can see that, OPC global servers and stuff definitely are optional. But you see, I got to have the tags, readers, middleware, and a server application that's provided for most applications. Now the question now, how does this RFID work? Well, tags and readers use different transmission mechanisms for whatever frequency band they're in. We'll look at two of the most common for passive caders. They usually read at UHF speed, frequencies 400 to 900 megahertz, or high frequencies, which is 13.56 megahertz. Now, let's look at the physical layer. And basically, it's a coupling of the passive tag and the reader. There's two types of coupling, how they connect to each other. There's inductive or magnetic coupling, and it's basically tags that touch the surface of the antenna or inserted into some kind of reader's case or something. Or there's a backscattering coupling, and it's designed for tags that can be read at distances, from 3 feet to 300 feet. And backscatters also, it basically is a reflection of radiation. So, now you're going to hear the term continuous wave or CW, and basically all this is an unmodulated sine wave, and it's used to supply power to a tag. So if I've got a tag that, a passive tag, once the reader hits it with this continuous wave, it now then powers up that tag. Backscatter modification uses, ASK or a combination of ASK or PSK modulation techniques. The reader has definitely its own transmitter receiver circuits. The reader can modulate, basically based on the signal end, 100% to as little as 10%, just a couple of different ASK modulations to what could be used. Now, remember, communications are always half duplex. You're not going to transmit and receive simultaneously at the same time. And granted, what's that do? It minimizes interference. It allows for environments where multiple readers could be stored that, so then it makes it a little bit more secure. Now, some of the standards also specify use of some of the techniques we've talked about at the physical layers, as far as maybe some security, some spread spectrum, frequency hopping, and direct sequence spread spectrum can be used. Now, you've got that high frequency tag communication. It uses what they call it. Basically, it's a tag with you're assigning time intervals or slots to be able to know when you're going to be broadcasting. So the interrogator or the reader transmits signals to mark the beginning and the end of each slot. Slots don't have to be equal size, and the number of slots can be regulated by the reader. Just to give you a rough idea what it kind of looks like in that protocol, that stack protocol. So just knowing that they're different sizes, the slot F everyone uses just kind of lets things get back in sync. Now let's look at UHF tag communication. Now, UHF readers support what they call Generation 2 protocols. And basically, a Generation 2 protocol just has a different communication technique between tags and readers. The first technique is reader selects tags by transmitting a bit mask. And you've seen it, you've done bit masks. What with your subnet mask, right? Same types of things. The second technique, readers can be used for inventory purposes by isolating product by repeatedly querying information from the products to try to get like products all grouped together. Because just think about going to a grocery store, you usually have all the Cheerios to be relatively close in the same area. But when I'm doing the cereal aisle, I need to skin it, keep processing down and narrow down and say, okay, where's just the Cheerios? Where's just the Cheerios of regular size versus family size or super size box? So it's just this repetitive process that's going to keep narrowing that down. The third technique, readers alternating, it's kind of going each tag individually and, just polling pretty much each one to try to get that stuff. Now, there's three methods to manage the population of tags. I can select, and it's basically just a series of commands to get to a particular segment of the products. Inventory send a series of queries to get information from a tag. Or access, I'm going to get one or more commands to get multiple or a single tag at a time. Now, here's just kind of a structure of a tag identifier. Now, the minimum amount of information that's required is contained. You're going to need the EPC code. You're going to need the CRC and a destroy password. Now, destroy password is a code that is programmed into the tag when it's manufactured. And then once somebody transmits, the tag is permanently disabled and can't be read or written to. So it has some benefits there. Now, there are other things you got to worry about with this. Is now, what about if do I get collisions? Now, we talked about in wireless, we came up with a couple of techniques to avoid collision of data. In your NET175 class, you came into a couple also. But in this case, a collision is basically what? Transmit and receive at the same time would result in a collision. Now, some tags and readers do not support collision handling, but the UHF says, hey, it sends out a verify ID command. The tags reply with its code, CRC, destroy password, and then it kind of proceeds to select whatever range it wants of tags and repeats to get everything. So it kind of goes through a process, verify itself and then process through it. Now, if there's a collision, you can what? I can calculate a number that becomes a slot number, which then can be, reprocessed. So I can kind of back things off a little bit. So I can have the reader says, hey, I can't receive. If I don't receive a reply in enough time, it assumes there's a collision occurred, backs off a random amount of time, and then rebroadcasts. We saw that in the security chapter in wireless earlier. Now, as far as the MAC layer, a lot of those are physical layer issues. Now let's look at the MAC layer. And what's the MAC layer responsible? It's setting up what? Transmission parameters. Bit rate, modulation type, frequency range. If it's a frequency hop, what is the sequence? So there's definitely different types of tags are different. The data rates for tags change. Anywhere from, 200, and basically it's different between the United States and Europe. So you get different regions. I can get 200 tags per second, or I can get, maybe up to 140.35. That's always interesting to get that kind of but different data rates. Now, another way of communicating with devices is near field. Now, how many of you have used your phone to buy something at McDonald's or tickets, or that's what near field communication, or exchange songs between two iPhones, near field communication. It provides short range wireless connectivity between devices. It's based on 18092 RFID technology and a 21481 ISO standard. It requires basically what? Little or no configuration by you other than turning the feature on, and you got to be relatively close to each other, about an inch and a half away. Now we get definitely some different data rates going through. Let's see, come on. Now, some of the examples we use, PayPass, PayWave, discount coupons, business cards, imaging, debt cards, you name it. You're pairing your Bluetooth without entering a PIN. Some of the operational modes of near field communication. You got listening, polling, read write, card emulator, initiator, target mode. So different ways that near field, how it's operating. Now, it has 4 different types of tags and devices. Each one is designed for something different. And they communicate slightly differently, different formats, different speeds. But first thing, a capable device has to be able to poll. It has to be able to identify the tags and devices within its range. And then it can store memory. It can store the device, what the tags can be used. How much information you can store varies. So it's just a lot of information. Now, near field communication is I can process in the 13.56 megahertz unlicensed frequency band. A couple of different modulation techniques can be used. And modulation varies between 10 and 100%, which is similar to RFID. Now, to transfer between two smartphones or you've got a couple of different data exchange rate it employs. So it just gets you a rough idea of the message structure, so you can tell it's not something that you can probably write a whole textbook on just this kind of information. Some of the challenges that are being faced, it's impact on corporate networks. You think, well, wait a minute, they're the ones that put it together. But think of how much, if you think about Walmart and say how much product they have and how much data, and when they're doing inventory and stuff, let's say they want to query all their products to keep their stocks inventory on every 15 minutes to keep it up to date. How much data that's going to be passed through their network on there. Their inventory systems, keeping all that up to date. How often do I want to interrogate it? Scanning a lot of network traffic. I got to make sure that the network's available. You never think about a Walmart store making sure that it's got to have its network up maybe 99.999% of the time, just to make sure that I can use this technique, this technology in a way that I'm not going to lose any money. Storage. How much data are you going to store? Some of the privacy laws are now saying you got to store tons of information. So now you got tons of information that's got to be stored. Then managing the quantity of RFID devices by itself becomes a costly issue. Now, is there some security risk with this? Yeah, it does, and most of it's centered around privacy. Because in some cases, the information that RFID is pretty much radiating most of the time. Your passive tags don't support any authorization or encryption security. So it does become issues. Now, granted, tags and data can be locked. Make sure you have to have a password. You can have a blocker tag, which then in the presence of that tag, it can disable unauthorized users. So granted, this is a really quick summary of RFID and near field communication, but I think hopefully gives you a sense of where this industry or this part of the wireless industry is going and some of its issues. So if you have any questions, give me a call. Talk to you later. Bye-bye.